starting back off from where we left off, right? We're talking about spanning tree. Why does it exist, right? We already talked about the foundation. Why do we have it? It's meant to prevent loops. It's one of the three major functions of the switch, right? Three major functions of the switch: forwarding, learning, preventing loops using spanning tree, right? And so one thing you'll have to know on the CCNA is in depth about spanning tree, about how to do the calculations, how to, you're on the exam and you're like, it gives you a diagram like this, and it's going to ask you who's the root switch, right? Okay, what are the root ports, right? What are the forwarding ports, right? You're going to have to answer all of these things, and in your mind, because again, you only can consult yourself on the exam. You have to be able to answer the why, because if you're able to answer the why to yourself in your own brain, there's no doubt that you'll be able to pass the exam because you know it. You've done it. You wrote it down on a piece of paper. You answered the why. You've done the calculation on your own. Done. Easy. So what I'm doing now, went ahead and created a lab, right? Created a lab. I have my bridge IDs above all my switches. We have 3 switches: switch 1, switch 2, and switch 3. And we're going to go ahead and convert, right? We're not going to jump into the switches, right? We're not going to jump into the switches. I'm turning them on, but we're not going to jump in. We're not going to do anything, manipulate anything. We're going to first convert this, right, with pencil, piece of paper, or whatnot, figure out the why, right? And then we're going to go ahead and go into the switches at the end of the lab and say, did what we do match up? Okay. So there was a little website, and I'll put it in the chat, that I love, that I used when I was studying my CCNA. Real simple, straight to the point. I'm sure you guys know that the CCNA, that book, dude, it's large. It's all over the place. I'm sure you guys can agree, right? I always recommend everybody don't just use that one resource, right? There's plenty of other resources you guys can use to go ahead and understand the concept, right? The proof, trying to get the proof of concept of what something means, right? So I just put in the link, right, to the webpage, but I linked it specifically to the STP section. Okay. And so, of course, go through it. And of course, if you want to jump in and say something, be like, hey, Dave, this is what have you, because I'll stop and ask questions. Feel free to put your hand up or just unmute yourself and be like, hey, Dave, I like to answer it, what have you. But we're going to go ahead and converge this topology, right? All right, so let's go ahead and get started. Let me go ahead and pull my pen out because we're going to use that a lot, right? And let's talk about this, right? So, like before, right? With spanning tree, we want to create a one-way flow of traffic, right? We don't want to loop. We don't want things going in circles and circles and circles like last time, right? Because if you guys remember, without spanning tree, things were just going, right? We need to make sure we got one way, one flow of traffic, right? And how we complete that is spanning tree, right? And so how spanning tree does it, first they have a thing called the spanning tree algorithm, right? And so between these switches, right? Between these switches are frames, right? Frames. We can't call it packets because it's not at layer 3, so we're going to call them frames. So we got frames going back and forth between the switches. What is that called? Those frames are called BPDUs, right? And so what do they share, right? They share information so that this spanning tree algorithm can go ahead and process, right? And so a couple of things that's going to be included in that BPDU, the bridge protocol data unit, is going to be the root switch ID, right? And typically it's going to be the switch's ID, the sender switch's ID. So whoever sent is BPDU, right? The root cost, right? The cost to get to the root, what have you, from that switch's perspective. And of course, the hello, the max age, and the forward delay timers. So you guys are probably thinking, right? Why the hell is this important? Why is the CCNA telling me Why is CCNA telling me to understand hellos, max age, yada, yada, yada? Why do I need to know these finite details, right? So the thing is, right, with, with anything, right, routing, with security, with switching, you're going to have to know the details if you're going to be a good engineer. That's just point blank, period. And from a security standpoint, somebody can hack you off of the littlest thing. They can do an STP attack, right? From a routing and switching standpoint, if you don't know how hello message are, hello intervals are, right? If you don't know what forward delay timers or what timers are, you're not going to understand egrip. You're not going to understand OSPF or BGP, right? The big words that you see on socials, in job interviews, in these wish lists of job postings. You have to know the fundamentals, right? And that's at the CCNA. CCNP, cool. If you want to go higher and of course elevate, perfect. But knowing your CCNA to a core, to the point where it's second nature, you have fun, right? Let me get off my pedestal. Let's go ahead and jump back into this, right? So I'm doing a packet capture, right? This lovely program called EvenG. We're doing a packet capture on gigabit 0/2 on switch 1 to gigabit 0/2 on switch 2, right? And what we're doing is we want to go ahead and take a look to see what's traversing in that wire. We have no PCs. I want to see if those BPDUs that I told you guys about, it's being sent between these switches, right? And this whole broadcast domain, right? Okay, so let's take a look at how that looks. Let me go ahead and grab a random one. Okay, so here's the BPDs, right? And you guys can see it. It's called STP, boom. So we open up the payload, right? We open up the payload of the frame and we see a couple of things, right? It's going to give us the protocol identifier, protocol version, all the boring stuff, right? What are we looking for, right? We're looking for the things that we need to perform, so the switch can perform the spanning tree algorithm, right? So we have the root identifier. Remember, I told you it's going to give us, this BPDU has to give us the root information. So it's going to give us it. Hey, here's the root. Here's the bridge ID of that root, okay? The root bridge priority, the system ID, and the MAC address, right? The system MAC address for that switch. That's the bridge ID, okay? And just to explain, because I know somebody's going to ask, right? This root bridge system ID, it relates to the VLAN it relates to the VLANs on that switch. So if I'm sending a BPDU for VLAN 2, this root bridge system ID extension is going to be 2, right? And so you guys are probably thinking, okay, so how is the bridge ID built? So a real bridge ID would be just the priority and the system ID together, right? And so the system ID extension and the priority, you add those together, right? So whenever we look at the bridge ID from a switch standpoint, it's going to say 32,678 plus VLAN 1. So it's going to be 32,678. I'm sorry, 32,769, right? And we can go check that in switch 1 because we're capturing on switch 1. So if we go here, right, go on switch 1, we look at it, show spanning tree. We can look at all our spanning tree information. We go ahead and check here. Exactly what we see, right? 32,769. We're not going to see the system ID extension. It's just going to go ahead and, hey, we're going to go ahead and add this together. Perfect. That's for that VLAN. And we're going to see the MAC address, right? These two things count as the bridge ID, right? And of course, you see it here. The bridge ID for this switch, boom, right? If you ever run a show spanning tree, first it's going to show you the root bridge ID, but it's also going to show you your bridge ID, okay? All right? And just to correct myself, right? So I told you guys they wouldn't actually show it on the show span tree on the switch. You guys can kind of make sense of it here, right? This is the system ID extension. So this is telling me, hey, the priority is 32,678 and the VLAN number, VLAN 1, because it's showing me all the information, right? The port role and status and interface and cost, priority number for this VLAN, okay? Right? And we'll dig a little bit deeper, but I just want you guys to take a look at this. And of course, there's other things here that we spoke about that get sent through a BPDU. We got the hello timers, we got the max age, right? We got that. We got the forwarding delay timers, right? A couple of things that are sent out, right? And you guys can see it. It's right here. All that is sent on a BPDU that's sent between switches. And again, no IP address needs to be on, it doesn't need to be on the, no IP address needs to be on these switches. They communicate via layer 2. So they communicate via MAC addresses, right? You see it in the packet capture in the back, okay? So that's how they communicate. BPDUs are all communicating via layer 2, okay? So, right? So they're sending these messages together, right? They're trying to figure out, hey, I'm gonna get in this same room together, AKA your broadcast domain, because there's no layer 3 boundary or a device that has an IP address, right? That's a router. If that's not here, and we're all switches, we're all in the same broadcast domain, right? We don't have any different virtual local area networks or VLANs. We don't have any segmentation there. We're all in the same broadcast domain. So we're all in VLAN 1, okay? So we're sending BPDUs. We're trying to figure out who's the root bridge for VLAN 1, okay? So how do we elect? How do we do this election? How do we figure out, right? So first, it's a couple of elections we need to do. First, we need to figure out who's the root switch, okay? So how do we do that, right? We first go ahead and take a look who has the lowest bridge ID, right? And so what that means is who has the lowest priority and the lowest MAC address when you compare the two values, right? So if I look at all these switches, who has the lowest priority, okay? And we look at the priority and we see, priority is the same, perfect. We're gonna move on to MAC address. And who has the lowest MAC address, right? And so, of course, we see the priority is the same. Let me get my little pen. See, the priority is the same, 32,769. So we're all talking about VLAN 1, right? So now we need to go to the next election point. When we go look at the second part of the bridge ID, we need to go ahead and look at the MAC address of the system MAC address for these switches. So I see 5,000.00001.00000. I see 2, and I see 3. So anybody can answer. Who is going to win this election to be the root bridge? And why? You can unmute yourself, ask, take a shot. Again, guys, we're all learning here, so take a shot at it, or what have you. If you guys want to pass it up, it's all good.
So I would think it'd be switch 1 would be your root bridge.
Why?
Because since they both have the same priority, and then it would be the case of the MAC address, and since that's the lowest one, that would be the one I would go with here.
Exactly. Simple as that, guys. Simple as that. Okay. So we see, right, and if we look in depth, right, we look in detail, exactly. And thanks again, Pete. If we look in detail, right, all the values for the MAC address match up until that 8th number, right? And that's where you go ahead and see what's that difference, right? And we're going for the lowest number. Go ahead and write in your notes. It's something that I learned when I was at Cisco, and my mentor, David Langley, taught me this. Whenever you're doing an election for any protocol at layer 2, it's going to go with the lowest number, right? If you're going for an election process at layer 3, it's going to go for the highest number, right? That's most of the time the case. There's certain things where that doesn't always apply, but most of the time, layer 2 is the lowest, layer 3 is the highest, okay? So like Pete was saying, we're looking for the lowest. All the values look the same all the way up until that 8th number. 1 is the lowest. So guess what? Switch 1 is our root. So let's go ahead and mark that. Go ahead and erase everything, right? Okay. And so with spanning tree, we got port states and port rows. Okay. So we're going to go ahead and mark this as our, oops, I think that's a bad color. Let me go ahead and erase that. Let me give it a king color, right? So here's our king, right? Here's our root bridge, switch 1, okay? Yep, Pete, yeah, that's a good one, Pete saying in the chat, he would call it the most experienced and oldest, right? So, and he's accurate. We'll touch on that a little bit later, but he does make a good point, okay? And Daniel, I see your shortest path. We're gonna get there. We're gonna get to path. We're gonna get there in a second, right? When we start doing convergence is what we're doing, right? So we got this, right? We have our root bridge, right? And so this is the switch that's in charge of making sure traffic is passing everywhere, right? Because it's the switch that calls the shots, right? It's the king of kings within this broadcast domain. Okay. So of course we know, the different port states and roles within spanning tree. You can block a port, you can be forwarded, you can be designated, right? But with spanning tree, right? If it's a root bridge, it always needs to be available. It cannot never be available, right? So this switch is, a root switch, it's always going to be forwarded, right? So that port state and role is going to be forwarding, right? And it's going to be a designated port, right? And we're calling it a designated port because it's designating to just forward traffic. It is not designated to block. It's designated to forward traffic, right? So the port role is designated port, right? And the state is forwarding, okay? All right, I hope that makes sense. Let's keep going, right? So now that we have our root switch, right, our king of the broadcast domain, right? He knows his port states and roles. Perfect, right? We got that squared away. We decided who's the king. But now what do we do with our other switches, right? We need our other switches to communicate with the entire broadcast domain because just like we talked about in the previous session, if we don't make sure that we have one path to the root or one path outside to the internet, what have you, and that root may be, the switch that's right under that firewall or that router, what have you. And that's typically how people program it. We want to make sure there's only one path to it, right? Because if we have multiple layer 2 paths to it and the spanning tree doesn't exist, we're going to have loops, just like we saw last time, right? So another election process that's going to happen, right, is between these non-root bridges, right? And we're going to give that the color, let's give that the color blue, right? Let's give it the color blue, right? We're going to give it the color blue, right? Non-root switches, okay? So with the non-root switches, right, it's going to go ahead and do an election process. It's going to say from each switch, who has the shortest path to the root, right? Switch 2 is going to go ahead and communicate with switch 3 and do that, right? And try to decide who has the shortest path to the switch, right? Based on my own ports on itself. So switch 2 is going to say, hey, to get to switch 1 through switch 3, maybe this link costs 2, right? I'm sorry, this link costs 4, and this link costs 4, right? And this link only costs 4. Again, with layer 2, we're going with the lowest cost, right? So if just getting to the root is just 4 on this link and 8 on this link, guess which one I'm going to go with? The one with the shortest path, like Daniel said, right, in the chat. So this is going to be, you know what? Let me not confuse you guys. Let me pop that out of there. Let me get yellow and do that, right? So this, right, this is going to be my root port, okay? This is my port, right, that is closest to the root because I need to identify that. I need to know, hey, packets coming to me, right, that are still framed, I need to know where to send it, right? Because this tells me where to go. I need one path, right? I need to make sure I identify that. So I'm identifying this election process. I'm identifying locally what's my shortest path to the root. This is my shortest path, right? And how is that out, that that calculation, that math is being done by the BPDUs? They're still sharing information, right? If we go back, let me go ahead and X this out. If we go back to the switch, let's go look up, right? Here's the cost. They're sending that information within each other. Those BPDUs are constantly being sent, right? So this is how that calculation is happening, right? So, all this math is being done free, right? Of course, on the exam, I'm teaching you guys this way so you guys can go ahead and learn how to do it on pencil and a piece of paper, because if you guys can do it on pencil and a piece of paper, on the exam, you will be flawless, okay? So we got our root port, right? And we're going to do the same thing. We're going to do the exact same thing. Switch 3. Hey, who's the closest to the root? Which port is close to the root? Is it gigabit 0/3 or gigabit 0/0 through switch 2, right? This only costs 4. This costs 8. This is going to be our root port, right? Perfect, right? And typically, right, your port role is a root port on these non-root bridges, right? But what state are they in? They're forwarding. They need to go to the root. The root is the end all be all, right? So it needs to be in a forwarding state. It needs to always be available once I decide who my root is. What's next? Because we can still have a loop, right? We need to decide between the non-root bridges, switch 2 and switch 3. Where are we going to block, right? Because if we don't block this link, we're going to have a loop. And this is what spanning tree is all about. We're going to say, hey, what are we doing, right? We're going to go ahead and say who got the lowest number, right? Who's this, who's that, right? Okay. And so that's what it's going to do amongst, and Cisco likes to call it a shared Ethernet, right? This link, right? Who is the switch with the lowest cost to reach the root, right? That's one of the elections, right? That's one of the questions they ask each other, right? On this link, right? And they're both the same. They both have a cost of 4, right? And typically these elections, they don't have one criteria. It's always a second or third or fourth one, right? If we know the cost is the same, which is 4 to get to the root, we need a tie. We have a tie, so we need to go ahead and go to a tiebreaker. In the case of a tie, the switch with the lowest bridge ID becomes a designated switch, right? So the name of these switches aren't non-root bridges anymore. We need one switch to be a designated switch. And the other switch, right, is going to be the switch that's a non-root switch, but but one of its ports is blocking. Okay. So let's look at this, right? So Pete, help me out. I'm pulling you in. You volunteered yourself. Okay. So in the case of this tie, right? In the case of this tie, who's going to be the designated switch?
So out of those two, since the same exact election priority to actually grant whatever the king was, you then remove the king from that entire scenario. So whatever is the second one would be this switch would be switch 2, because that has the lower MAC address compared to the third one.
Excellent. Excellent. So now this is our designated switch. Thank you again, Pete. Excellent breakdown. So we have our designated switch, right? So what does that mean, right? So on our designated switch, that means we don't have to block at any of the ports. We have a designated port now, right? And that designated port is going to be forwarding, right? It's going to be forwarding, but it's going to be a designated port. It's not our root port, right? But it's our designated port. It can now forward traffic, right? Now, Pete, since switch 3 lost the election, what is switch 3 going to do with that port on that same shared link to switch 2?
It's going to block it.
Why?
Because that's the irrelevant port. That's the irrelevant question. If I already have a direct route to switch 1, it's not the necessary one.
Exactly, right? And don't get confused by route, guys. We know what Pete was talking about, right? We want one path to the root within this broadcast domain. Within spanning tree, what it's trying to solve is create a loop-free path, right? And so we have a loop-free path if we take a look at it, right? If we, bring up some arrows, right? Let's bring some happy stuff out of here. Where's my handy dandy stuff, right? If the computers were plugged into switch 2, right, traffic can go, whoops, make that a little bit, there we go. Oh, that's not what I wanted. There we go. Where is, there you go. Well, that works. Right, so I'm just gonna use this. If traffic wanted to come from switch 2 and PCs were there, they can go either to switch, they would go ahead and go either switch 1, or they can go out of this port, the designated port, right? Of course, it's gonna be blocked by switch 3, but it can leave out there, right? If we have PCs on switch 3, it can leave, go to switch 1, do its root port, and of course, nothing's gonna be sent out of the block port, right? So now, let's go ahead and erase this. We got one path, right? We got one path to get to the root, right? And so we have a loop-free topology, right? And that's it. That's it. We converted spanning tree. We did a convergence, right? And that's typically all that we need to do for spanning tree. That's it. And you guys, and of course, just to share a little bit about myself, whenever I was studying for the CCNA, before I let I know the switch is going to do it, right? And we're going to check our work in a second. I know the switch can do it, but you guys can go ahead and do these calculations yourself on a pencil and a piece of paper. If you guys are able to do that, right, man, you guys will be on the exam and they'll ask you a question like this because you're going to see it. Who's the root switch? Who's the root port? What's the port state? Why? You guys will be able to answer this if you guys do practice, right? And so you guys can use this diagram. Typically, this is what you'll see, that web page that I share with you guys. You guys will see it. And yeah, you go ahead and get this. Exactly, Pete. Yeah, why take these extra turns on the street when I can drive straight in a straight line? And that's typically what spanning tree is doing, right? We don't want to take, if I can get from switch 2, if I can get to switch 1 directly through its root port, why would I want to go ahead and go from, switch 2 to switch 3 to switch 1, right? And that has to do with the cost, right? With spanning tree, it's all about cost. And the reason why you want to practice this now, the other part of the CCNA, you learn about routing protocols, you learn about OSPF. Things about cost will be there, right? You get to your CCNP. If you do want to go for your CCNP, things will be about cost there, right? You learn, you go into cybersecurity, you learn about things about, certain things about hacking, what have you. There's certain criteria and elections and what have you to meet certain things to see what's the vulnerability, what's not. These are things you have to know. That's why the core of everything on the technical side of IT is routing and switching, computing, A+, or what have you. Okay. And guys, that's it. I gave you guys the CCNA page, it's really helped. They speak in plain English. We went ahead and converged topology manually. And that's it. This is the 3 functions of a switch, right? And so last but not least, we're going to go ahead and close up. Let's go ahead and check our work, right? Let's go ahead and make sure what Pete said, it matches up. So let's see if switch 1 is the root, right? Boom, right? How can we confirm it's the root, right? We go ahead and do a show spanning tree. We're going to go ahead and look at the system address, right? And compare it with the bridge ID, right? If that's the same, boom. This is your root switch, okay? That's how you'll be able to identify.
Hey, Dave, okay. Wouldn't it also just say it is the root?
No, sir. Because every switch, and I'll show you guys, every switch, when we run this show spanning tree, what this is saying is, hey, this is the root ID, and this address is the root. Don't get confused, because that's going to be on every switch. That's why you have to compare what's here in the root bridge ID and what's in the bridge ID for the system. Okay? And so let's take a look at that. Let's open up switch 2 so I can show you guys what I'm talking about. right? Oh, well, yeah, it'll tell you, of course, the root bridge. Perfect. Yep. So I take that back. Pete, you're right. It'll tell you who the root bridge is, right, and how to get there, what have you. So yeah, I take that back. Which one will tell you this is a root bridge? I apologize. I'm thinking about Juniper. So yeah, too many vendors I'm touching. But yes, Cisco, it'll tell you who the root is, the cost to get there, what have you, on the root ID on the non-root switches. Of course, this is the designated switch. And it'll tell you its bridge ID, okay? So we look at it, we take a look, and let's verify Pete's. Okay, Daniel, I got you. I see your back. So verifying Pete's convergence, none of our ports are blocking. We have a root port, the gigabit 0/2, so that's right? And none of our ports is blocking. Let's go ahead and check switch 3. See if we have anything that's blocking there. Let's go ahead and pull that up. Show spanning tree. Boom, right? So that port that connects to switch 2, just like Pete said, right? It's blocking, right? The status is blocking and that role is alternate, right? And you guys are probably thinking, the hell does alternate mean? The fuck does that mean? The fuck does alternate mean? It means exactly what it means, right? So if any case, this root port, gigabit 0/3, stops working, the same calculations are going to happen on switch 3. Within the entire topology, this broadcast, it's going to say, hey, I need another path to the root. This port is the alternate path because with spanning tree and the creation of it, it's there to help with redundant paths, right? And with redundant paths, we can have loops. Spanning tree says, hey, we're going to do these calculations. We're going to set roles, the role and states for different ports so that we don't have a loop. And we're going to say which one is blocking, which one is forwarding, right? If we set a port has an alternate port, if the root port goes down, we lose a path to the root. We can go ahead and go through this one. And let me show you, right? Let's go ahead and shut down the root port, which is gigabit 0/3. We shut it down. Okay, it's going through the different states with spanning tree, because of course this uses the old spanning tree. Okay, so we're going through listening state, right? Okay, it's learning state. Okay, so now it's in a learning state. All right, it already said it's the root port, but it's still going through. It's not forwarding yet. Okay, boom. So now gigabit 0/0, right? To get to switch 2, that's now the root port. Okay, and what spanning tree did, since that port is shut down, they took it out of the spanning tree table. It's gone. Gigabit 0/3, done, out of there. It's not being used. Okay, so that's the pros of having an alternate port, having a spanning tree algorithm and spanning tree running, because again, we can go ahead, exactly, Pete. If there's an accident in the road, we can take a detour. That's exactly it, right? Perfect analogy, Pete. So, and that's it. Guys, any questions? Any at all? Okay, all right. Oh, Pete, go ahead.
I was going to say I'm good here, but do we have any examples where any of the costs and the other values are different?
Oh, yes. So typically, right, and you'll hear about this in OSPF, eGrip, a couple other things. There's different costs. And let me pull up that web page that I sent you guys. There's different costs for different links, okay? Give me 1 second. Yeah, let me pull up that page I sent you guys. Perfect, okay. Oops, let me take that out. You know what, let me just do this. There you go. Okay. So can you guys see my screen? Okay, perfect. So read what it says, right? The default port cost is defined by the operating speed of the interface, right? So we can't necessarily set the speed, right? It's based on, we can go ahead and override it just for calculation. We can do that with eGrip and spanning tree and OSPF. But by default, it goes based off of the operating speed of the interface. So Pete, if we have a 10 gig interface, that costs us 2. If we have a 1 gig interface, that costs us 4. If we have a 100 meg, fast Ethernet port, the cost is gonna be 19, right? And if we have a 10 meg, just an Ethernet port, it's gonna be 100, right? And so that calculation is the same. So if Jerquan, you write on a piece of paper, maybe the link between switch 1 and switch 2 is a 10 meg link, and Jerquan says between switch 3 and switch 1, that's a 10 gig link. That costs us 2, right? And between switch 2 and switch 3, we have a 1 gig link. That's 4. Do your calculation. That's where that would come in, Pete, right? That's where it would come in to everything that we did, your spanning tree algorithm or what have you. Does that make sense, Pete?
Absolutely, that makes a lot of sense. And also, the election would also be taking over again, wouldn't it?
Exactly, right? And because again, if not even within the device, if Jerquan is doing the convergence, he's looking through, he's saying, okay, now let me do the math again. Who has the shortest path, right? Switch 2, if it has a 10 meg link to switch 1, it's going to say, oh, no, I'm not taking that way. That cost is 100, right? Jerquan is going to say, hey, switch 2 to switch 3, that has a cost of 19. It has a cost of 4. And switch 3 to switch 1, it has a cost of 2 because it's a 10 gig link. Oh, my cost is 21 to get to switch 1 through switch 3 versus it'd be a cost of 100, right? Even though it's right there, right? It's directly connected, doesn't mean it's going to take that path. It's all about cost, right? Cost being a link, cost being whatever metric, whatever the protocol is going to use. So that can be layer 2 at spanning tree, that can be OSPF, that can be eGrip, whatever, BGP, whatever you want to call it. Everything has costs, timers, etc. All these algorithms are in place, so it'll do the math for you to prevent any loops, make sure you got one path, etc. This is why learning the fundamentals of routing and switching at a CCNA level will be the building blocks and the fundamentals for you guys to move forward to other things. Daniel, I'm sorry, go ahead.
So the shortest cost you have is a cost of 2 for the 10 gigabyte link. But what if I have a 4 gigabyte link or 100 gigabyte link or terabit links? Is that still a cost of 2?
Mm-hmm. Yeah, so it depends on, and that's a good question. It depends on the current setting that you have for spanning tree, right? So similar to eGrip, because I'm studying eGrip now, right? If you use the default settings, after a certain speed, the costs are going to be the same. 10 gigs, 20 gigs, what have you, they're all going to be 2. Unless you use a higher, right? Use a certain setting that's going to say, hey, I got higher links, adjust this, right? And that's what you can do. You can go ahead and...
So you would change the reference bandwidth then?
You wouldn't change the reference bandwidth. You would change what the spanning tree algorithm, what it's doing, and what that'll do, that'll go ahead and change the values for the different interfaces that we have on our switch. So if Daniel has 10 gig links, 25 gig links, 2.5 gig links, anything over a gig, right? That's going to be the same. Changing that setting, and I'll send that to you after this. I can't tell you off the top of the head. You change that setting within the switch, it'll be totally different metrics, right? It's similar to eGrip, right? ERGRP, and using default mode to do the algorithm versus using eGrip wide metrics, right? Which are typically used for links higher than a 10 gig link, right? Because anything beyond 1 gig, right? Those costs, those values for that link is the same thing, right? And that's not going to benefit me. That's not going to benefit the switch or the router to do the calculation. Okay? Does that make sense?
So yeah, so this is when you probably want to use the longest path cost. Is that correct? With the short path cost?
Exactly. And thanks for reminding me. Yeah. So it's gonna be the setting that you change to use the long metrics, right, within spanning tree, and then it's gonna change those interfaces.
Thank you.
Yeah, no problem. Guys, any other questions? All right, folks. Well, I'll go ahead and end it. Thanks again for joining. This was a fun one. And again, we're done with the three major functions of a switch. We're still at layer 2, right? We're still at layer 2. We're going to still stick to our journey. We're going to talk about CDP, LLDP, and a couple of other things and stuff like that before we move to layer 3. There's a couple of things we're going to talk about. So just get ready. We'll talk about CDP. We'll talk about trunking, talk about VLANs, and a couple other things that you'll need for your CCNA. All right. You folks have a great night, and I'll see you guys in 2 weeks.
Hey, David.